Imagine gazing down at Earth from hundreds of miles above. You see swirling clouds, vast oceans, and continents painted with diverse landscapes. This is the unique vantage point of remote sensing. This technology allows us to observe and study our planet from afar, revealing its secrets in ways never before imagined. Remote sensing is like seeing with a powerful, all-seeing eye. It doesn't rely on direct contact. Instead, it uses the principles of physics and wave mechanics. By reading the faint whispers of energy emitted and reflected by Earth, remote sensing unveils a tapestry of information. This information is hidden from our naked eye. Think of it as a conversation with our planet. Earth speaks in a language of energy, constantly emitting and reflecting electromagnetic radiation. Remote sensing technology acts as our translator, capturing and interpreting these signals. It then transforms them into images and data that reveal the hidden patterns and processes shaping our world. This remarkable ability to observe Earth from a distance has revolutionized our understanding of the planet. It provides insights into everything from weather patterns and climate change to deforestation and natural disasters. With remote sensing, we gain a powerful tool to monitor, manage, and protect our fragile home. To understand remote sensing, we must first delve into the fascinating world of electromagnetic radiation. This energy travels in waves spanning a vast spectrum from radio waves to gamma rays. Each part of the spectrum carries unique information about the objects it interacts with. Visible light, the portion we see with our eyes, is just a tiny sliver of this spectrum. Remote sensing harnesses a much broader range, including invisible wavelengths like infrared and microwaves. These wavelengths interact with matter in distinct ways, providing valuable clues about the composition, temperature, and other properties of Earth's surface. When electromagnetic radiation interacts with an object, it can be reflected, absorbed, or transmitted. Remote sensing instruments, known as sensors, detect and measure the radiation that is reflected or emitted by Earth's surface and atmosphere. By analyzing the patterns and intensities of this radiation, scientists can identify different materials and features on Earth. For example, healthy vegetation reflects strongly in the near-infrared, while water absorbs most of it. This allows us to differentiate between forests, deserts, and bodies of water. The heart of remote sensing lies in its sophisticated instrument sensors. These technological marvels act as our eyes in the sky, capturing the faint whispers of energy emanating from Earth. Sensors come in two main types, passive and active. Passive sensors, like those found on most satellites, rely on detecting naturally occurring radiation. They act like sophisticated cameras, recording the sunlight reflected by Earth. Active sensors, on the other hand, provide their own source of energy. They emit pulses of radiation and measure the time it takes for the signal to bounce back from the target. Imagine a bat using echolocation to navigate in the dark. Similarly, active sensors, such as radar and LiDAR, use emitted radiation to see through clouds, rain, and even vegetation. This provides valuable data, regardless of weather conditions or time of day. These sensors are carried aloft on a variety of platforms, each offering unique advantages. Satellites orbiting hundreds of miles above Earth provide a global perspective and continuous coverage. Aircraft offer greater flexibility, allowing for targeted observations and higher resolution imagery. The vast amounts of data collected by remote sensing platforms must be transmitted back to Earth, processed and analyzed to extract meaningful information. This intricate process is crucial for transforming raw data into valuable insights. Data transmission relies on sophisticated communication networks. Satellites beam down their observations to ground stations, while aircraft and drones transmit data wirelessly. Once received, the raw data undergoes rigorous processing to correct for atmospheric distortions, geometric errors, and other factors that can affect accuracy. Think of it as developing a photographic film. Just as a photographer uses chemicals to reveal the hidden image on a negative, remote sensing analysts use specialized software to process and enhance the raw data. This reveals the intricate details and patterns hidden within. This processed data is then transformed into various formats, including images, maps, and three-dimensional models. These visual representations allow us to see the unseen, revealing hidden patterns and processes that would be impossible to detect from the ground.